Welcome to Lesson 4. It's the final lesson of Unit 2, Equality and Congruence. So, right now, what I want you to do in your group is to see that what do you think, what does your group think the difference is between equality and congruence. So pause the video and discuss this. Okay? The big difference between equality and congruence is the figures that are used. For equality, we need to look at the root word there. Equal. There's going to be an equal sign. So this is going to be with anything with an equal sign. So like our lengths have equal signs. Our measures of angles, those have equal signs. Equality deals with exact units and lengths. Congruence, on the other hand, deals with the basic idea of a figure. Like you can say that AB is congruent to CD, and you can say that angle A is congruent to angle B. Now, both of them can be discussing the same thing in a sense, because segment AB has a length of AB, but it's just the particulars of how we use them. So equality has to do with lengths and measures. Congruence has to do with the actual figures. We have some properties of equality and congruence. There's the reflexive, the symmetric, and the transitive property. The reflexive property is pretty straightforward, and it is kind of silly. The reflexive property says that things are equal to themselves or congruent to themselves. So like for equality, we could say that the length of AB equals the length of AB. You can think of the reflexive property like a mirror. It's taking something and reflecting it upon itself. We could say that the measure of angle A equals the measure of angle A. Likewise, for congruence, you'd say that segment AB is congruent to segment AB, or that angle A is congruent to angle A. And again, I know this may seem silly, but it's just a part of our building block. We have to say this is true in order to build higher. Next we have the symmetric property. And the symmetric property is similar to the reflexive property, but not quite. If we say we have just a length of AB and it's equal to CD, what the symmetric property says is that we can just take these two and flip them about the equal sign. So this is the same thing as saying CD equals AB. These two are the same as the other. Likewise, if we have the measure of angle X, and we say that's equal to the measure of angle Z, we can also say the measure of angle Z equals the measure of angle X. And a similar idea comes over here with congruence when we actually talk about the figures. If we have segment AB and say that it's congruent to segment CD, we can also say that segment CD is congruent to segment AB. And it works just the same for angles. Okay. Our last property is the transitive property. And this one is something else that once you see it and once you realize it, you'll say, okay, well that's right. For the transitive property equality, let's say that we have three segments. We have AB, and we say that it's equal to CD. We also say that CD is equal to EF. Well, if AB equals CD and CD equals EF, we can conclude that AB also equals EF because of that commonality. They both share this CD that they're equal to. Well, if they're equal to the same thing, they need to be equal to each other. And there's a similar idea over here with congruence. Let's say we have angle A and it's congruent to angle B. We also know that angle B is congruent to angle C. Well, if A is congruent to B and B is congruent to C, then we can say that angle A is congruent to angle C by the transitive property. Now we're going to talk about just some specific properties of equality. And there are 5 of them. The first is addition. The addition property says that we can add the same number to any side of an equation. Now we know we're working with equations because of this equal. So let's just say we have the equation 3 plus 1 equals 4. Well, the addition property says that if we add a number to each side of the equation, it's the same thing. Nothing really changes. So let's add a plus 2 to each of those. So we have 3 plus 1 plus 2 equals 4 plus 2. Does anything really change? Is the equation different? I mean, here it says 6 equals 6, and before it would basically simplify to 4 equals 4. But did we break any rules? Is 6 equal to 6 and is 4 equal to 4? Yeah. So that's the addition property of equality. The next property of equality is subtraction. And it works just the same. You'll see that all these properties work very similar to each other. So subtraction. Let's say that we just have 5 equals 5. The subtraction property says that we can subtract the same number from each side and we wind up with the same thing. So if we do 5 minus 4 equals 5 minus 4, we get 1 equals 1. And again, the equation really doesn't change, it just looks different. We still have that equality there. The third property of equality is multiplication. And then the fourth is division. And they both work exactly the same way as addition subtraction. If we have 3 equals 3 and we want to multiply by 2 on each side, nothing really changes. Same thing if we have 6 equals 6 and we want to divide by 2, nothing changes. So our preservation of the equal sign is still there. Nothing changes that equality. Now the final property of equality. Substitution. And this is a little bit different. For substitution to work, we need to have a variable in our equation. So let's just have x plus 1 equals 3. Now what this says is that we can substitute a number in for that variable to make this true. The key here though, it needs to be a specific number in order for this to work. We can't just substitute in any number for it to work. So what number would we substitute in to make this work? Well, we need something that'll make 3. We have plus 1. Well, what plus 1 is 3? 2. So this says if we let x equal 2, this is true. So we do 2 plus 1 equals 3, and 3 equals 3. So it is true. And that is all the properties of equality.